Okay, welcome to this video, and in this video I'm gonna prove. Okay, so we have two questions here. So what are the questions? First question is f r to r f of x is equal to 3x plus 4 is bijective. Okay, so we have to prove here that this function is what? Bijective. Its domain is real numbers and codomain is also what? Real numbers. Second question is f r to r f of x is equal to x squared plus 4 is surjective but not injective. Got it? So in the second question we have to prove that this function is surjective but not injective. Okay, so let's start the solution. So we're going to do the first question. So okay, it's the solution, and the first question is what? F r to r. Okay, so f r to r, meaning from real number to real number. This is the domain and this is the codomain. Codomain, and the function is f of x is equal to 3x plus 4, and you have to prove that this function is bijective. What does bijective mean in the first place? So if a function is said to be bijective, it means that it is both injective and surjective. Okay, so a function is bijective. Okay, that implies that the function is injective as well as surjective, and injective means 1 to 1. Okay, 1 to 1. Surjective means on to, and bijective means 1 to 1 on to. Did you get it? 1 to 1 on to. What is injective? Again, 1 to 1 means. 1 to 1 means that there is no two element in the domain that map to the same element in the codomain. Does that make sense? There are no any two element or more than two. Okay, maybe three. Okay, so there are no two or more elements in the domain that maps to one element in the codomain, meaning one element in the domain maps to exactly one element in the codomain. Okay, so no two elements map to one element in the codomain. This is what injective mean. Okay, so in other words, like this. So this is the domain, and here you're gonna have the codomain, and no two of them map to the same element. Okay, so this is not allowed. This is not allowed for being injective. Okay, so if you have a function which doesn't do this, meaning it is not like, I've told you what is this. Okay, it doesn't do this, it means that function is injective. Surjective means what? That all the element in the codomain are mapped to some element in the domain. It means for all y in C, there is x in D. Does that make sense? For all y in C, there is x in D. This is what surjection means. This is what surjective means. Okay? So now we're going to prove that. How are we going to prove? Okay, so let's have a look. Okay, it means for this we have to prove that it is both injective and surjective for the first one. Okay? So let's prove that it is both. So what are you going to do? We're going to prove that it is 1 to 1 or injective first. Okay? So what are you going to do in the first place? We're going to start with a contradiction. What contradiction? Okay, so let x1, I'm going to name it x1, and x2 be two elements such that f of x1 is equal to f of x2. Does that make sense? So what I've written here is I have supposed that there exist two elements. Okay, so let x1 and x2 be two elements such that f of x1 is equal to f of x2. It means I've supposed in the first place that there are two elements in the domain that Okay, so there are two elements in the domain that map to the same element. I've started with the contradiction. Does that make sense? What have I started with? I've started with the contradiction, that I'm supposing that there are two elements in the domain such that their output is same. Does that make sense? So if it is injective, then what is going to happen is that if this is true, then what should happen? This should imply that x1 is equal to x2. Did it make sense or not? Did it make sense or not? What I'm saying is, if you have, this is D, this is C, if x1 is mapping to this, x2 is mapping to this, and if there are two distinct elements, then this is not what? Injective. But if x1 and x2, they are the same thing, this is the same thing, it means x1 is equal to x2, they are the same thing, then this is injective. Does that make sense? So if you have this condition, it means this should imply this, to be injective. So let's do the procedure further. Okay. So what are we going to do next? So we're going to solve for this. F of x1 is equal to f of x2. And what is going to be f of x1? 3x plus 4. So it's going to be 3x1 plus 4 is equal to 3x2 plus 4. Okay, 4 cancels out. And you're going to have what? 3x1 is equal to 3x2. And this will give you what? That x1 is equal to x2. What does that mean? It means if f of x1 is equal to f of x2, it means then you have x1 equal to x2. Okay? So if f of x1 is equal to f of x2, this implies x1 is equal to x2. So the function f, okay, so f is injective. Did you get it? Okay. So if f of x1 is equal to f of x2, this implies that x1 is equal to x2, and this is why. So f is injective. Easy. Now we're gonna do for surjection. Okay. So I'm gonna prove that it is surjective. Okay. So let's start with that. So we're gonna. So what you're gonna do is, now you can let there be any element. Pay attention here. Okay. So you have this the domain, this is the codomain. To prove that this is surjective, what you're gonna do is, we're gonna pick up any element from the codomain, any arbitrary element in the codomain, and if there exists an element in the domain for that corresponding element in the codomain, what does that mean? That means it is surjective. Let me repeat. If I pick up any arbitrary element in the codomain, and if there exists an